Hello, my name is Hao Tang. I'm from Borough of Manhattan Community College, City University of New York, Computer Science Department. The following is the short video lecture discussed about photogrammetry and aerial imagery. It's part of participation of NSF iGETT remote sensing project. This is the outline of my lecture. First, I'll introduce the photogrammetry technology, show different type of aerial photographs, and then I'll introduce some important concept of photogrammetry. After that, I'll explain some technology and application to do the 3D measurements using single and stereo aerial imagery. Finally, I'll show some photogrammetry application and the data available online. Photogrammetry is the science of making measurements from aerial photograph. It is originally invented in the 19th century after photography has been invented. The first aerial photograph captured from airplane for mapping purpose. Compared to the photogrammetry, remote sensing is relatively new disciplinary. It started since 1960 after the first satellite launched. Remote sensing focused more on acquisition of information about an object or phenomenon using physics, where the photogrammetry focused on exploitation of camera geometry. There are other disciplines related to the photogrammetry and remote sensing, including computer vision, pattern recognition, and machine learning. Some try to recover 3D geometry from aerial imagery. Some can automatically classify objects into different categories according to their physical property. In this video, we are going to focus on aerial photograph. There are different types of photograph depending on the sensor's orientation relative to the ground. Most of aerial photographs can be classified into vertical or oblique photographs, where vertical aerial photographs are acquired with the camera pointed vertical down or slightly tilted. The ground aerial imagery by vertical photograph is square in shape, so there is no geometric distortion, and they are commonly used for remote sensing application. The oblique photograph can further classify into low oblique and high oblique photographs according to the orientation angle of the camera. Because the ground feature and object are distorted in scale, they are not often used for measurement and mapping. First, I'd like to introduce a few important concepts of photogrammetry. Focal length is a very important property of camera. It's defined as the distance between the camera lens and image plane. It shows the scale of aerial photograph. The flying height indicates the height of the aircraft above the ground. Fiducial marks are the center of four sides of aerial photograph. The principal point is the center of photograph, which also the intersection of lines connecting two opposite fiducial marks is the point on the ground where the optical axis of the camera points. Next, let's talk about image scale. It is the ratio between the size of object measured on the aerial photograph compared to the actual size of the object in the real world. In this equation, Si is the size of object on the image, and Sr is the size of the same object in the real world. Scale can be defined as the ratio between the focal length and the flying height of the aircraft. So this image shows the scale setting available in ArcGIS software. 1 to 1000 means 1 inch object in the image corresponding to 1000 inch in the real world. If the image scale and the focal length are given, then the flying height can be also calculated. By this equation, divide focal length by the scale, so we can calculate the flying height of the camera. In this example, focal length is a half feet. The image scale is 1/2000. Then the flying height is 1000 feet above the ground. Given a single image, the height of building above the ground can be calculated using this equation. Both D and H are the 2D measurements on the aerial photograph. D is called the relief displacement, the image projection of the vertical building, and R is called the radial displacement, which is the distance of building top from the principal point. In this example, the flying height is 1000 feet, which is calculated in the previous slide, and to follow this equation, we can compute the height of the building is 125 feet. The previous slides show the calculation of building height from a single image. We need to measure distance between the top and the bottom of the object. Sometimes it's hard to accurately measure it due to the quality or resolution of aerial photograph. In this case, we can also use another photogrammetry technique called the stereoscopy to measure 3D information of the object from a pair of overlapping aerial photographs. Let's first take a look what is the principle of stereoscopy. The parallax is the displacement of the 3D position on two images caused by different position of observation. It relates the 3D position of the object from the camera. The parallax is reversely proportional to the distance of 3D position from the camera, which means the larger the parallax, the closer the object in 3D from the camera. Let's see this example. The displacement of a pencil between two images is quite large. It's much larger than the displacement of the building from two images. So from this example, we can easily figure out the pencil is much closer than the building from us. And there are two concepts we need to understand before we can do the 3D measurement using the stereoscopy. The first one is called the absolute stereoscopy parallax. It is the photo distance between the principal point on one photograph and the corresponding principal point in another photograph, also called the conjugate principal point. The second concept is called the differential parallax. It is the difference between stereoscopic parallax at the top of the building and the base of the building. In this example, PT is the parallax of top of the building and PB is the parallax of base of building. Now we know the parallax is the principle used to infer the 3D information of object from the camera. We can follow this equation to measure building height using stereoscopy. Small h is the height of object. Capital H is the flying height we assume is given. dP is the differential parallax, the difference of displacement of the top and the base of an object. P is the absolute parallax. It is the displacement between the principal and the conjugate principal. So we can follow this equation to compute building height, which is 39 meters in this image. Many applications in photogrammetry are listed in this slide. Aerial photographs are available to download in many websites, including USGS, ArcGIS, and so on. These are the content questions. Number 1. What is the difference between photogrammetry and remote sensing? Photogrammetry is one of the important techniques of remote sensing, but it has different focuses from remote sensing. Number 2. What kind of measurement can photogrammetry do? It can measure 2D or 3D of objects from an aerial imagery. Number 3. How the flying height be measured by a single image? The flying height is calculated by dividing the focal length by the image scale. Number 4. Can a building height be measured in a single aerial image? The answer is yes. Number 5. What is the principle of 3D measurement using stereo images? The principle is the parallax of an object is reversely proportional to the 3D distance of the object from the camera. Number 6. List a few applications of photogrammetry. Here is the answer. These are the references being used in this lecture.